All right, let's continue our ionic compound discussion. So what we're going to talk about today is naming the most basic ionic compounds. So we're going to go forward, going from the formula to the name, and we're going to go backwards from the name to the formula. So just an introduction, the most basic of naming. So here's how we name binary ionic compounds. So binary ionic compounds, that word binary, prefix bi means two. So this is just going to be two atoms that come together, sodium and chlorine, oxygen and magnesium, calcium and fluorine. So two atoms that come together. First, we're going to write the name of the cation or the name of the metal. We don't do anything to that. We just simply write down the name. So sodium, potassium, magnesium, whatever it is, just write it down. The anion or the nonmetal, we're going to write the name of the anion plus IDE. So the base name of our anions, this is a nice little chart that's going to get you familiar with base names. So if we're using fluorine, the base name would just be fluor, we add IDE. For chlorine, the base name would be chlor, add IDE, chloride. For oxygen, the base is just the O and the X, add IDE, so oxide. So this is just a nice slide to get you familiar with it as you're starting to write them out. So let's systematically go through our sodium chloride examples. So everybody knows that sodium chloride table salt is called sodium chloride. Let's systematically go through and see how we came to that. So sodium is Na. So we see Na, we write the name of the metal, sodium. Cl is our nonmetal, so that's chlorine. We're going to keep just the base of that name. So we're going to keep the CHLOR, so the chlor. Drop the rest of it, add IDE. So that's how we get to chloride. And then we just simply take those two pieces of the puzzle and write them together. So just simply sodium chloride. Going from the formula to the name is very, very easy. Going the other way takes a little bit more thought. It takes a few more steps. So we're going to talk now about how we go from the name to writing the chemical formula. So here we see potassium bromide. So the first step is going to be to get the chemical symbols onto the paper. So I see the word potassium. I look at my periodic table and I see that the chemical symbol for potassium is K. Then I go to bromide. Bromide is our nonmetal, and that is bromine. So brom was the base, IDE for bromide. So going backwards, it would have been bromine. So I write BR for bromine. Now that I've determined the chemical symbol, I just can't simply write those two down. I have to think about the charge, right? So if I'm writing an ionic formula, I have to make sure that it's neutral. So determine the charge for potassium. He's in group 1A. He will give away one electron, so he'll have a positive 1. Bromine is in group 17 or 7A. He has 7 valence electrons. He will steal 1, so he'll have a -1 charge. We flip-flop the charges. So this becomes the subscript on bromine. This becomes a subscript on potassium. So 1 and 1. We just simply write KBr, and that's our neutral compound. So that's the thought process for going from the name to the ionic formula. And this just stair-steps you through the same process. So we'll do one more example together, and I've written out the steps in words so that you can see this as I'm doing it. So the example we're going to do is up here at the top, sodium oxide. So the first step is to write the chemical symbols. So what's the chemical symbol for sodium? That is just Na. What's the chemical symbol for oxide? Well, oxide is oxygen, so the chemical symbol would be O. Step 2 is determine the charge when these become ions. So sodium is in 1A. It's got 1 valence electron. It's going to give it away. So sodium would have a +1 charge. Oxygen is in 16 or 6A. He is going to steal 2 electrons. So when oxygen becomes an ion, he's going to be a -2 ion. Step 3, flippity-flop the charges. So this 2 is going to be the subscript on sodium. This 1 will be the subscript on oxygen. So that's the flippity-flop. So we would write Na2O. And again, that 1 is implied. If it makes you feel better to write it in there. And then always double check to make sure that this is electrically neutral. So each atom of sodium brings a +1 to the table, and there's 2 of them. So that's a +2 charge. Each atom of oxygen brings a -2 to the table, and I just have 1. So that's a -2. So +2, -2, they're neutral. Another skill that you're going to want to practice, the next video is going to be talking about exceptions to the rule. So this is the most basic, easiest naming of ionic formulas. Next, we're going to talk about exceptions to the rule. Hope you guys found this helpful.